Hey guys, okay, so here is first section of chapter 3, derivative of a function. So actually, you already know how to do this. We're just getting deeper into it, you know? So derivative of a function, we haven't said the word derivative yet, but we have been doing this. So we have, this should look very familiar. We have been finding a derivative using limits. So we found speed, that's a derivative. What is a derivative? A derivative is slope. That's all it is. A derivative is slope at one point. So when I say slope at one point, we're talking about, I'm going to show you another random piece of paper, okay? So we're talking about, let's pretend you're on like a roller coaster. Remember that roller coaster example that we did in class? Let's pretend you're on this roller coaster. You have to go one way on a roller coaster, okay? It has to go this way. So on a roller coaster, you'd be going down the roller coaster, and then you're sitting here, and that 2x4 on your head would be like right horizontal, right? So then you would have a zero slope down here, and then you have a positive slope because you're increasing, and then you would have a zero slope, and then you'd have a negative slope, and then slowly change to a zero slope, and then you'd continue until you broke your freaking neck. So right here, bad things happen because this is not smooth. So that means that you're going positive slope, and then you broke your neck. So all of a sudden it changes to zero slope. So that's no good. So this has a slope everywhere except for right here. So all of these points, all these little points have slopes. Like this is a negative slope, this is a negative slope, this is a zero slope, this is a positive slope, but just a little bit. This is positive slope, but more. This is positive slope, but even more positive. So we're talking something like that. So when we say slope at one point, it looks something like this. So let's say you have, let's say you have some function that looks like that, so you're going to draw it in, and then you want to slope at that point itself. You're drawing a tangent line, right? Just like we did in chapter 2. So you draw a tangent line, and you're finding the slope of that tangent line. So really, all of these letters, what they represent, so this x and f of x, that's like our point, right? And then what we're basically saying here when we're finding the limit as h approaches 0 is we're saying, okay, let's go ahead and call this length h. So if we call that length h, then this is x plus h, let's say. And then if we were doing the slope at 2 points, it would be like f of x plus h minus f of x, so y minus y over, and then this minus this. So what's x plus h minus x? It's just h. So this is actually the slope formula, but we're using h here as like, you know, an addition to x. And then we're saying h is getting closer and closer to 0. So really h is really, really small, so we're finding slope at one point. So that's how we're finding the derivative, or that's how we're finding the slope at one point. Okay, so I know that was a lot of explanation for some of you who already maybe remember this from last year, okay? And this is how we write derivative as well, f prime, okay? So we have the definition of derivative, and then we have the alternative definition of derivative, which is still slope at one point. So this works too, okay? So the alternative definition of derivative, and you have to know this as well, so it, you know, it looks the same, f prime, this is f prime. So here's the difference. This is our, you know, limit the way that we've been doing it, and this will give you a slope at one point. This should look very familiar. This is a slope usually using 2 points. So if this is a slope usually using 2 points, what we can do is we can use a limit and say, well, but now we're saying x is getting really, really close to a. So really, like x and a are basically the same point. So that's how come this is slope at one point where x equals a. The alternative definition, you have to know this. You have to know this is called the definition of derivative. Like I will test you on both, and you have to be able to do both, okay? So here's a little picture of that. So if we needed a little picture. So here is our, you know, x, and actually I used a right here, but we want x and a to basically be the same point, so they're getting closer and closer together where x is becoming a, and then we just want that slope right at a. okay? So something like that, and they're both, you can see, just like a 1-point slope. All right, so the notation, how do you write it? You can write it a bunch of different ways. These are all legal. So f prime, which is the same as f prime of x, which is the same as y prime, which is the same as, we haven't seen this yet, dy over dx. This means the derivative of y in terms of x. That's really what it is. And then this, if you think about it, is this, like, it kind of makes sense that it would be the derivative in terms of x of something, right? So the derivative of y, this is the derivative of something in terms of x. So this means the same thing. And then y and f, always interchangeable, so this is okay too. All right? What you cannot write is dy. You can't just do that. That's not legal, okay? So it has to be in terms of x. The way I usually write it, because I am lazy, I write it like this and I write it like this, okay? But this is very, very, very correct, all right? Okay, so they all mean the same thing, the derivative of f, all right? Or the derivative of y, however you want to say it. Okay, so we're gonna find dy over dx, that means find the derivative, using the definition of derivative. Okay, definition of derivative is the h approaches 0. So they're both limits, but we have to do the h approaches 0. All right, so we're gonna plug it in to that equation. So you might wanna write it, you know, the first couple times you do your homework, you wanna write it down, the actual formula. And then you're gonna start to plug it in. And when I plug it in, I go, okay, so everywhere there's an x, I write x plus h, and then 2x, now I have 2 times x plus h, minus the original, so here's the original, all over h. So we've been doing this, right? Okay, it seems as though we need to multiply this out, and it's been a while, so basically you have to FOIL it, and then multiply more. So as a little reminder, this is what you get. So you get a cubed plus 3a squared b. So the a cubed is cubed squared to the first power, and then b cubed, b squared to the first power. In the middle, there's the 3 and the 3. Okay, so if you forgot, this has to do with Pascal's triangle as well, but there you go. Multiply it out, or, you know, remember this, okay? So then you multiply everything out. You should be able to do it. Don't just copy me. But you multiply everything out. So I multiplied that out. It's all here. And then I distributed the -2. And then I distributed the negative. And then I used my pencil and I was like, oh, x cubed subtracts away. The 2x subtract away. Okay, so what's left? So what's left, sorry, I made a mistake here, is I have this one, this one, this one, and this one. I see an h in every term, so I factored out an h. This becomes 3x squared, and then I have an h here, and then I have an h squared here, and then I have a -2 here. And then on the bottom, I still have an h, and then I can divide away the h's. That will always happen, 100% always happen. And then I have my final answer, because right here it says h goes to 0, so that means that this is 0, and this is 0, so it's 3x squared plus 0 minus 2, so 3x squared minus 2. This is my formula for all the slopes possible of this function. So if I wanted to find all the slopes possible here, and I had a formula for it, I could be like, oh, when x equals 1, plug it into my formula, that's what the slope is at x equals 1. So that's what this is good for, okay? And then we're going to use it a lot in calculus, but we're just getting used to the calculation part first. Okay, so let's try another. So for b, you're going to find y prime, and it says, actually this one says y prime equals. Okay, so if y prime equals this, I want you to actually be able to tell me what was y. So if I give you this as the derivative, you have to be able to tell me what was the original function. You know how like this one, you had an original function and then you plugged it in? Well, what happens when you plug it in? This part is f of x minus f of x. So that is the original function. So I look over here. This must be the original function. So y equals 1 over x. Okay, what I did here is I'm just like working out the problem. So what do we have to do when we have like complex fractions? We multiply by the LCD. There is 1, 2, technically 3 denominators, but the denominator under the H is a 1, so I don't have to worry about that. So I multiply by LCD over LCD, and then I multiply the top. I get an X left over. I multiply here, and I get an X plus H left over. There's a minus in between, and then the H and the X that just, you know, is right next to each other. Okay, don't multiply it out, just like leave it right next to each other. And then clean up the top, so subtract and then minus, and you get something like that. The H's divide away. And then once the H's divide away, you plug in your 0 and you get negative 1 over x times x plus 0, which is just x squared. So negative 1 over x squared. Okay, so here's your derivative using your definition of derivative. Okay, so the next one, it says find dy over dx. So find the derivative using alternative definition. Okay, so alternative definition, you have to use this. So plug in the limit as x approaches. So the limit as x approaches a of 4x cubed minus 4a cubed all over x minus a. All right. And then we're going to go ahead and work with this. So how can we work with this? Oh, we probably have to factor, because eventually we have to get rid of this part on the bottom, right? So factor out of 4, and then you realize, oh, I factor out of 4, and then I have an a cubed minus, or x cubed minus a cubed. That's SOAP. Remember your SOAP. SOAP is same, opposite, always positive for the signs. So you have to know how to do SOAP, okay? Difference of cubes. Look it up if you don't remember, or ask me. Okay. And then you keep going, and then you get this, and then it says, okay, now plug, once you divide away the bottom, then you want to plug in. So this says x goes to a. So every time you see an x, now you have to write a, okay? So then this turns into a squared. This turns into a times a. All right, write it out, and then clean it up. So there's your derivative. You would have gotten the same answer using definition of derivative, but alternative definition gives you this. If it's definition of derivative, my answer would actually be 12x squared. And then alternative definition, you're always going to have an a instead of an x, because all the x's turned into a's. Does it matter? Yeah, it does. Okay. So here's another one where it's kind of like this one, and it's like, okay, here is the derivative. So if this is the derivative, what is the function? So here we said this is f of x, so 1 over x is y. That was the original function. What was the function here? Well, this is f of x and this is f of a. So this part right here should be my f of x. That's my original y value, or f of x value. Okay. And then you're going to go ahead and factor. Oh, yeah, remember that? We can factor the bottom. And then you divide away. And then you plug in. And then wherever you see an x, you have to plug in an a, right? So then you have root a times root a, which is 1 over 2 root a. In calculus, we can go ahead and leave the radicals on the bottom. It's fine. Luckily. Okay, last one, actually. So last one on these notes. It says f of x equals, it gives you a piecewise function, and then it says find the slope at 1. All right, if you have to find the slope at 1, you have to find the slope using 2x squared, and you have to find the slope using 2x plus 1. So you have to find both. I would advise you to try the definition of derivative, and then for the other one, try the alternative definition, but you have to do both. Don't just copy me like a big fat cheater. And if you look at it, you realize, like if you plug in 1, so you can do that first actually. If you plug in 1, you get 2, and then if you plug in 1, you get 3. So technically it's not continuous. If it's not continuous, it's not going to have a slope, just so you know. So it's not going to have a slope at 1, but I want you to be able to find the slopes. So I found the left slope, and then if you find the left slope, eventually you will get 4x. And then if you find the right slope, eventually you will get 2. And there's 2 reasons why this doesn't exist. One, the slope on the left and the slope on the right are not the same at 1. And 2, it's not even continuous. So even in the beginning of a problem, if this was multiple choice, I'd be like, oh, it does not exist. Because it's not continuous. It can't have a slope. Okay? If you're on a roller coaster and it's broken in the middle, there's no slope. When you die on a roller coaster, there's no slope. Okay? All right, on the back of these notes, this is your first homework for tonight. So all you have to do, there are 1, 2, 3 questions where you have to do an A and a B. So you have to find the derivative 2 ways. So that's 1, 2, 3, 4, 5, 6 questions for here. And then for these 2, you're given some sort of slope already. You're given some sort of slope. All you have to do is identify what's f of x and what's a. What the heck is Miss Tan talking about? Remember when we did this one? You had to identify. So I want you to identify. That's it. So these 2 should be, these 2 could literally be like, 5 seconds each. Okay? So you have 6 problems and then like 2 really quick ones. All right? So 1A, B, 2A, B, 3A, B, and then these 2. All right. The answers are on the bottom. Don't be a cheater. And then your next homework is going to be right here as well, just so you know. Okay? All right. Good luck. I will see ya so soon.